Hi, this is Dr. John Bergduff. In this video, we're going to take a little look at simplifying complex fractions. Now, in Tom's videos, which you've already seen, he talks about how to simplify complex fractions using two methods, and he does some great examples. I thought I'd do an example that's just a little bit different and show you how to work this using both methods, which I think would be interesting to see side by side. And then you can decide which one of these methods you think works best for you, because ultimately it will be your choice. So this is an example of a complex fraction. It simply is a fraction that contains fractions, a big fraction that contains little fractions. And one method for simplifying these, because it's clearly not simple, is to write each of the numerator and denominator as single fractions and then divide the fractions. You almost look at this as two separate exercises. Do what you need to do to combine the quantities in the numerator. Do what you need to do to combine the quantities in the denominator, and then take a look at it from there. So let's see how this would work. Here's the question just rewritten so we can see. If I were to focus on the numerator only for just a minute, I see that I've got three expressions there, and I would need to find a common denominator. The least common multiple of these denominators would have to be x squared. That x is clearly a denominator and a factor in both denominators, and we need to take the highest power. So we need to think about, what do I do to each of those fractions in the numerator so that the denominator will be x squared? Now 3 is not a fraction at all, so I'll have to write it as 3 over 1. And then to get a common denominator of x squared, I'd have to multiply numerator and denominator by x squared. 18 over x. I need x squared. I've already got x. If I just multiply by one more x in the numerator and the denominator, I'll have it. And guess what? 21 over x squared already has the least common multiple that I want, so I'm in good shape. And we're going to continue working in the numerator, in the big numerator of this overall fraction later, but you can see how this is all going to combine, I think, pretty clearly. In the meantime, let's also be looking at the denominator and think about the least common multiple down there. I'll use a different color. Here, every denominator has a factor of x. We need to take the highest possible factor, so that would be x cubed. I'd have 1 over x, and to get an x cubed in the denominator, I'd have to multiply by an x squared. Then I have 3 over x squared. I need an x cubed, so I'll need to multiply by one more x in the numerator and denominator. And then finally, the 28 over x cubed already has the x cubed denominator. Okay, that looks kind of nice. Let's rewrite that with all of these as a single fraction. So in the numerator, you now have a common denominator of x squared. And combining the numerators, you'd have 3x squared minus 18x minus 21. That's everything in the numerator. In the denominator, you would have x squared minus 3x minus 28 all over x cubed. Now, what we've done at this point is we've created a single fraction in the numerator and a single fraction in the denominator. Now what we want to do is we want to visualize the main fraction bar separating the numerator and denominator as meaning division. So we're dividing the blue fraction by the green fraction, if I may say it that way. Let's go to another page and continue working. So I have in my numerator fraction, I have 3x squared, actually I have to look back, minus 18x minus 21. All of that is over x squared. Big fraction denominator, And then in the denominator, you have x squared minus 3x minus 28 over x cubed. That, again, think of that as a division problem. So 3x squared minus 18x minus 21 over x squared divided by x squared minus 3x minus 28 over x cubed. Now we build on what we know about dividing fractions. When you divide one fraction by another fraction, you take the first fraction and you multiply by the reciprocal of the second fraction. So you flip that one over. And technically what you would do is you'd multiply numerator by numerator and denominator by denominator. However, you're better off if you can see whether any of these expressions factor further. So let's take a look at that. So if I think about the first numerator, you might notice that first of all there's a common factor of a 3. Always look for a common factor first. That can make your life so much easier. And if I factor that out, notice how the numbers will become so much smaller. That would be x squared minus 6x minus 7. All over x squared. Not much I can do there, although there will be some simplifying. X squared minus 3x minus 28. We can go ahead and factor that now, I think. We're looking for two numbers whose product is negative 28 and whose sum is negative 3. How about x minus 7 and x plus 4? That would do the trick. Now notice we still do have a trinomial right here. We're going to need to factor that again. So continuing our factoring process, let's write that as 3 times, now two numbers whose product is negative 7 and sum is negative 6. That's pretty clearly x minus 7, x plus 1 over x squared, x cubed over here. Now, if all this factoring feels like a lot of work, at some point you get to the spot where you can sort of get out your aggressions by looking for common factors that can divide out and slashing away at them. So I notice, for example, that I have an x minus 7 in this numerator that would divide with the x minus 7 in that denominator. A little more subtle, I see that I have here 2 factors of x and here 3 factors of x. 2 of those factors of x will divide out and leave me with just 1 x in the numerator. Where does that get me? Well, let's write what we have left, because a lot of things divided out. 3, if you don't mind, I'm going to bring this x up to the front, just because I think it would look better. 3x times x plus 1. And in the denominator, everything's gone but x plus 4. Notice how much simplifies. Now, in our final answer, since our original problem was stated in terms of polynomials, we're going to want to write our answer that way as well. And all I mean by that is we're going to multiply the 3x out by the distributive law, and that would give me a final answer, I'm almost out of space, of 3x squared plus 3x over x plus 4. That's how you simplify that complex fraction using method 1. Now, there is a second method. We're going to do the exact same problem, but we're going to look at it with the second method. And then you can look for yourselves and decide which one you like. So this method, you're going to see a lot of the same things, but it's subtly different. What you do here is you multiply the numerator and denominator of the overall complex fraction by the least common multiple, or LCM, of what I'll call the wee contained fractions. So we're going to be a little Irish here. The wee little fractions, sure and be, we got to get rid of them. Okay, now, what I mean by the overall fraction is this entire expression over this entire expression. That's the overall fraction. So that's what I'm talking about there. And when I'm talking about the wee little fractions, it's all of these small fractions contained within the overall fraction. Now, oops, excuse me, got a little problem here. There we go. Now, what we do is we look for the least common multiple of the wee fractions. Looking in all the denominators, looking at the denominators of them, I have x's and x squareds and x cubes. The least common multiple of all the denominators would be x cubed. So this is probably not as clear as it should be. Multiply by the least common multiple of the denominators. Let's add that phrase. Of the wee contained fractions. So I'm looking to find, as if I was going to add all these wee fractions together, what's the common denominator between all of them? Now what you do in this method, which is different from the last one, is you take the entire numerator and multiply that by this least common multiple. And you take the entire denominator and you multiply that by the least common multiple. It's the least common multiple of all the wee fractions. The distributive law then tells you that you can take that quantity you're multiplying by and multiply it by every term. So we'd have something that looks like this. 3 times x cubed minus 18 over x times x cubed minus 21 over x squared times x cubed. That's the numerator. Same thing in the denominator. Multiply, multiply, multiply. That would give me 1 over x times x cubed minus 3 over x squared times x cubed minus 28 over x cubed times x cubed. Now what you want to do next is you realize that by doing this, you're essentially going to get rid of the fractions. Look at what can divide out here. If you think of, for example, in this term right here, the x cubed is x cubed over 1. Notice that this x would divide out into the x cubed and leave you with an x squared. Similarly, this x squared would divide out with this x cubed, remember that's over 1 too, and give you an x. Let's see what happens down here. This x, the first x, would divide into x cubed and give me an x squared. The x squared would divide into the x cubed and give me just an x. And the x cubes in this last term would completely divide out. Now that's a little bit messy. Let's rewrite it. So rewriting what we had on the previous page, we'd have a 3x cubed, we'll go back and forth, minus 18x squared minus 21x all over x squared minus 3x minus 28. I actually could memorize all that, amazingly enough. Now, if you notice when you do this little trick of multiplying by the least common multiple of the denominators of the wee little fractions, the fractions go away pretty quickly, and you get a fairly basic rational expression. Now, we do want to see if we can simplify that, so we factor out any common factors we see. I see a common factor in the numerator. In fact, now, it looks a little different from last time. I see that both the 3 and an x would factor out, and I'd be left with x squared minus 6x minus 7. No common factor to factor out in the denominator. But the x squared minus 6x minus 7, that factors. Actually, that will probably look familiar. We saw it already. And in the bottom, that also factors x minus 7, x plus 4. Then the x minus 7s divide out. multiply the 3x back across so that we have a polynomial over a polynomial, 3x squared plus 3x divided by x plus 4. So what you might want to do is watch this video a second time and just kind of look more carefully at how these two processes work out a little bit differently. Let's take a quick peek. Did we get the same answer? Oh, hallelujah, we did. That's wonderful. So you may like one of these methods over the other, or you might want to try both until you see which one works best for you, but they are both valid methods for simplifying complex fractions.